What is quantization in analog to digital conversion? Imagine trying to capture the sound of a guitar string vibrating or the temperature outside with a digital device. To do this, the device first takes samples of the analog signal at specific moments. But here's the tricky part. The original signals are continuous, meaning they can have any value within a range. When converting these signals into digital form, we need to turn these endless possibilities into a set of fixed, countable numbers. That process is called quantization. Quantization involves dividing the entire range of possible analog signal amplitudes into a certain number of levels. Think of it like breaking a long staircase into steps. Each step represents a specific digital value. The more steps there are, the closer the digital version can match the original signal. For example, an 8-bit analog to digital converter has 2 to the power of 8, which is 256 levels. A 16-bit converter has 65,536 levels. More levels mean finer detail and more accurate digital representation. When the analog signal is sampled, each sample is rounded to the nearest quantization level. This rounding introduces a small difference called quantization error. It's like trying to match a color with a limited palette. Sometimes, you can't get the exact shade, only the closest one. This error appears as noise or distortion in the digital output and can limit the accuracy of the conversion. In electronic systems, quantization is very important because it affects how well the digital data reflects the original analog signal. If the step size between levels is large, the digital signal may be rough or noisy. If the levels are very close together, the digital version is more faithful. The quality of the conversion is often measured by the signal-to-quantization noise ratio, which improves as the number of levels increases. Quantization is used in many everyday devices. Digital audio players convert sound into digital data through this process. Instruments like thermometers or radio receivers also relying on quantization to turn physical signals into data that computers can process. It's a balancing act. More levels give better accuracy but requiring more data storage and processing power. So, in simple terms, quantization is the step that turns a smooth, continuous signal into a series of tiny, discrete steps, making it possible for digital systems to understand and work with real-world signals.